Hi, I'm an old guy and I do maths, and today I want to talk about a thing called an effective interest rate. Um, this causes a lot of confusion, and I've been asked about it recently, so I thought I'd make a video. Now, there is a formula for the effective interest rate, and on many calculators there's a function that replaces this. So I'll just explain this before I actually explain what an effective interest rate is. So the formula for an effective interest rate is that the effective interest rate is equal to 1 plus the rate of interest that you're receiving. We're talking about interest being received in this case, over 100 times the number of compounding periods. So, for instance, if you put something on deposit at a bank for a year and there is one compounding period, that is 1. If you put it on deposit for a year but it compounds every 6 months, that is 2 compounding periods, and so this number becomes 2 and this number becomes 2. And the only other thing you have to do is, having calculated this, you subtract 1 and multiply by 100, and that gives you a percentage. And if this number is other than 1, the number that you get as a result of this will not equal your interest rate. That's the curious thing. Now, this has a lot of echoes of this formula down here, which is the compound interest formula. And I'm going to use this formula initially to demonstrate how the effective interest rate changes depending on how you compound it. So I've got a couple of examples, I think 3, set up on the next page. And what I'm going to assume is that we invest $1,000 at 12% per annum. And in the first instance, that investment has one compounding period, as in it goes for 1 year, and at the end of that year you get your 12% interest. That is in fact a simple interest calculation, but we'll run it through the calculator using this formula. So that's 1,000 times 1 plus 12 divided by 100 is 0.12. And we're going to raise that to the power of 1. And what we get is we get $1,120, which equals $120 in interest. The interest is this number here, the 1,120 minus the $1,000. Okay, so if we then take this and we divide it by 1,000, so I'll do that up here, 120 divided by 1,000, we will get 12%. So, sorry, I need to multiply that by 100 to get a percentage. But again, I'll do that on the calculator. 120 divided by 1,000, hopefully you can see that, times 100. And you get 12%. There's our 12% interest rate. But watch this. What I've done here is I've assumed quarterly compounding. So this compounds 4 times a year. Now, what that means for the calculation is that we have $1,000 times 1 plus 12 divided by 400, 100 times 4. and we raise that to the power of 4. And what we get is the following. So 1,000 times this plus this over 100 times 4 is 1.03. And we raise that to the power of 4. And we get that. We get 1125.51. We'll round that. Okay, I hope you can see that. Now, our amount of interest is 125.51. We haven't done anything else except alter the compounding period. We are still receiving 12% interest, but it is compounding every 3 months. And we get about $5.50 more. Now, so what's the effective interest rate here? Well, the effective interest rate is found by dividing this into our principal and multiplying by 100, which is what I did up here. We will come back to the actual formula, and I will put one of these values in, and you can see how that formula works. But for the moment, I'm just going to do this. So 125.51 divided by 1,000 times 100, and there we are. We've got 12. Can you see that? Let me get that into the frame. We've got 12.551% interest. 12.551% interest. Kind of interesting, no pun intended. Let's do that once more. This time we're going to do it monthly. And the reason I chose 12 is because it divides up nicely into months. So our calculation is 1,000 times 1 plus 12 over 1,200, which is 0.01. 1 plus 0.01 to the power of 12. N is 12. N is 12 in both of these cases. And what we get is we get the following. I hope you can see that. $1,126.83, we'll say. 1126.83. Do the interest calculation again. Interest is equal to $26.83. Sorry, $126.83, I beg your pardon. So that should be 1126.83. I skipped a step there, I apologize. Pop that into our calculator. 126.83 divided by 1,000, our principal, and multiply that by 100, and we get a rate of 12.683%, and that's our effective rate of interest. Now, what I want you to see from all of this is that without altering the interest rate, I have increased the amount of interest that one receives. Now, this is a very long way of going about it, just to prove the point. Let's go back to the formula. So, the effective interest rate is equal to 1 plus our rate of interest over 100 times n, whatever n is. We're going to get to that in a moment. Minus 1 times 100. So what we're going to do is we're going to take the last example here and see if we can get this to work for us. So that's going to be 100 times 12 to the power of 12. Okay, so let's try this. So it's 1 plus, sorry, our rate of interest, I beg your pardon, that goes in there. 1 plus 12 over 1200 is 0.01 to the power of 12. Work that out. We get that. Minus 1, so I'm just working my way slowly through this, times 100. And what we get is 12.68%. Now, allowing for rounding and so forth, I think that's pretty good. And in fact, if I round this to 3 figures, I would get 683. So 12.683, which is exactly what I got here. So I hope that gives you an insight into what an effective interest rate is and how it's governed by the number of times that the principal is allowed to accumulate and compound. The short way of working it out, I guess, is to stick it in your calculator. In most financial calculators and most graphics calculators, there's a little drop-down menu that allows you to do that. This formula here gives you the effective interest rate. You can work it out using a compound interest formula. You have to take another step, which is to work out the amount of interest that you've accumulated. Divide that by 1,000 rather, as I did up here, and multiply by 100. Anyway, I hope that this was helpful and useful. If it was, please like and subscribe, and I'll see you next time. Bye.